In this video, the learner will use inverse trig functions to solve for missing angle measures in a right triangle. So first we're going to examine a few equations and how we would solve these. So looking at 5x equal to 20, how would we get x by itself? Well, of course we know that we would just divide both sides by 5. Because we're multiplying by this 5, so to get rid of it, we would divide by 5. Well, in this equation, we have x plus 3 equals 9. To isolate the x, we would, of course, subtract 3. In this equation here, x squared equals 25. To get just x, we would have to undo x squared, so we would have to square root both sides to get the solution. Notice each one of these, we're performing an opposite or inverse operation. The opposite of multiplication is division. The opposite of addition is subtraction. The opposite of squaring is square rooting. Well, so now consider this equation. Sine of x equals 4/5. How would we undo the sine function to isolate that x? So in order to do that, we're going to have to introduce what are called the inverse trigonometric functions. So to do the opposite of sine, we have to introduce the inverse sine. And this is what that equation will look like when we solve for x. That sine to the -1, that -1 indicates that it's the inverse of sine. For cosine, we have inverse cosine, and we have inverse cosine of the adjacent over hypotenuse is going to equal our angle. For tangent, we have inverse tangent, and the equation is inverse tangent of the opposite over adjacent equals x degrees. Notice each one of these still follows SOHCAHTOA, but now the O and H, A and H, and O and A are inside each one of those equations. So let's talk about why. We want to solve this equation for x. So I need to undo that sine function. In order to do that, I have to take the inverse sine of both sides. When I do that, I'm isolating the x on the left and then taking the inverse sine of 4/5. So now what I can do is actually plug that into my calculator. I know what x is supposed to equal, so now I just have to put in sine to the -1, which is inverse sine of 4 divided by 5. And we get 53.13 degrees. So that is the approximate measure of the angle that we're taking that sine function of to get a ratio of 4/5. Okay, let's try a triangle example. Here we want to know what this angle is. We notice we're given the 10 and the 24. The 10 is opposite from x degrees. The 24 is the adjacent side. So we can actually use opposite and adjacent in the tangent function to help us solve for x. So we would set it up like we normally would. Tan of x equals 10 over 24. Then we take the inverse tangent of both sides, and we get the inverse tangent of 10 over 24 to put in our calculator. So put in inverse tan of 10 over 24, and we get approximately 22.62 degrees. That is the approximate measure of x degrees in our triangle. Here are two examples that I want you guys to try to solve for x degrees in each one of these triangles.